All right, so we have a slight introduction to combination notation. We tend to end up using this more in probability, but you'll find that this notation and the purpose of this is to help us out with the coefficients in Pascal's triangle, or if we're evaluating in the binomial theorem. So it's really cool to see how different branches of math are related to our current math at hand. So to start off, just so that you understand, whenever you see this notation, you'll notice that there's two numbers. In our case, it's 8 and 3. And they are enclosed in parentheses in sort of like a matrix-like style. This would be like 2 rows by 1 column. Not quite a matrix though. This is a shorthand for combination notation. So if we could kind of look at this, there's an 8 on the top, there's a 3 on the bottom as far as the number is concerned. So if you want to say this out loud, we would say 8, choose 3. So we're basically taking 8, choosing 3 combinations. And feel free, you'll research that into a stat class or a future section in this textbook. For the purposes of this section, we're just looking at a formula. So another way to understand this is just looking at how to plug things in. If we have 8, choose 3, this is telling us that n is equal to 8 and r is equal to 3. So the top number is n, the bottom number is r. So if we'd like to plug this into our formula, so remember, I'll write this out for reference. We see this on top, actually. I shall highlight it. We see this notation right here. If we would like to evaluate this, we end up looking at this as n factorial. So n is 8, so I'm going to rewrite this as 8 factorial over r factorial, so that's 3 factorial, multiplied by n, 8 minus 3, from there. And it should be factorial, so let me write that into the notes. I knew I was missing something. You will see that, I think, in your notes already. Okay, so it's a bunch of factorials. But before we try to, well, I mean, you could punch these into your calculator. I will show you a couple different techniques. Let's say we don't have the use of our TI. Just kind of notice some little nice, some nice shortcuts with factorials. What is 8 minus 3 factorial? That's 5 factorial. So kind of notice some patterns here. If you look at the two numbers in the bottom at the end, you see that the 3 and the 5 tend to add up to 8. And it kind of makes sense in the terms of the factorial. So we should have that. If you'd like to evaluate this by hand, what I always like to do is I take the larger factorial that I see in the denominator. So if you don't mind, I see 3 factorial and I see 5 factorial that are getting multiplied by each other. 5 factorial is something that I'm going to focus on, because we noticed in our previous findings that if you do have a larger number, like 8 factorial, you could start by knocking off the beginning factors. So 8 factorial starts off as 8 times 7 times 6. And we know it'll go 5 times 4 times 3 times 2 times 1. But that, my friends, is really 5 factorial. So if you notice, you could get rid of a lot of complications just by dividing out those common factorial factors. So if we were to do that, we divide them out. Same thing over same thing equals 1. So what do we end up getting? I'm going to have to move a little bit sideways. I'll go sideways. It's a little faster. We have 8 times 7 times 6 on top. And then 3 factorial, 3 times 2 times 1. And I could have multiplied 8 times 7 times 6 and then figured it out that way. But I would like to point out, as you do see common factors still. We do see that 3 times 2 equals 6. So that's another way. I was going to color code that for you. That's another way to show that you're dividing out common factors. So what ends up happening, your final answer, all you have to end up multiplying is the remaining factors on top and the remaining factors on the bottom. So my friends, 8 times 7 is 56, and we have 56 over 1. So finally, the value of 8 choose 3 is actually 56. So this is a nice way to do it by hand if the numbers are small enough or if the factorial factors divide out. But you've probably already guessed it. You could directly plug this formula into the calculator if you were interested in. So let's try that. And then I'll show you how to call up the notation as well. So let's kind of go through. Let me push back on the TI for you. So if you'd like to directly input the formula, we would have on top, we have 8 factorial. So I'm going to push the 8. And again, how do we get that factorial to show up? Press the math key, scroll over a little bit to probability, and we have 4. So that's going to be divided by, now here's where you'd have to be careful if you were typing the formula directly into the TI. If you're understanding, you have to make sure that your denominator is completely enclosed in parentheses so that the calculator does not read it differently. We would be looking at 3 factorial. So again, math key, scroll over to get the factorial. So that's going to be multiplied by another parenthesis, that's 8 minus 3, with a factorial as well. So let's pull that up. Again, math, probability menu, item number 4, and finally, close off your denominator. So that looks pretty much like what we have. Press enter, and you see right away we do get the 56. You could also take it if you were interested in, I'm going to recall it, second entry. If you wanted to do the math in your head, like 8 minus 3, not too big of a deal, you could just directly type this in, so then there's less issues with dealing with these extra parentheses. You would just make sure that your entire denominator was enclosed in parentheses, and you would still get the same answer. So that's a really cool way to look at it. But you've probably already guessed already, well, if my calculator can do factorials, can't it do combination notation as well? And yes, it can. So let me show you that. A few kind of nice ways to look at this. So let's go back really quick just to kind of review all the different ways to talk about N choose R. For example, 8 choose 3. If we were looking at this one more time, I'll show you over here, 8 choose 3. Another way to approach it or look at the notation is looking at it as 8C3. And see if I can kind of show you at the top. I will use purple, or maybe I'll use green because it's a little different. We could see it in a couple different ways. I'll show you, kind of depends on what TI you have. You could see it where you have an 8 first. On the same level, you have the C, and then you have the 3. Newer notations, if your TI allows for the subscripts, it kind of shows it a little bit better to be clearer that it is combination notation and not 8C times 3 or anything else. So we kind of utilize these 2 notations. It is also possible, depending on what type of operating system you have, it is possible that you could see it in this notation as well. But I'll wait on that one just in case, because most of us do have the TI-83 or the 84. So as you can see, we can go back to our calculator, and probability is the same menu as we use with our factorial. So let's just go back. I'll share that screen with you. And let's see if we can pull it up. Sometimes you have to press the N first and then the factorial key. So it kind of depends on what type of TI you have. So sometimes you'd have to press 8 first, then we go to the math menu, scroll over to the probability, and again, we will see item number 3, that is N choose R. So right away, that will leave us with the 8, and we can fill in the last part, which is the 3. Your calculator, you may see it slightly differently. But if we press enter, we notice we still get the same result without much work. So it's good to have the formula down if you're going to use it for something else. If you're strictly just asked to evaluate something with pure numbers, feel free to utilize your TI. I would like to point out just one more thing, just so that you kind of see it is possible. I do kind of remember when I was dealing with a TI-82. I know who has those anymore, just me. You guys all have your 83s, I'm betting. Let me go back and kind of copy so I can show you. When I see this on the TI, I think the 83 still do this as well. See if I can open this up just a little bit, make it a little larger so you all can see. It is possible that another type of notation you could see, you would end up seeing like the 8 first that you typed in, and then the TI would actually kind of just show this part, NCR, and then you would have to press the R part second. So kind of be on the lookout for how your calculator works. When you do use it, you will still see you still get the same answer. So it's another 56 in this case. So I hope this helps. It's a really, really cool way to figure out the parts of the coefficients in the binomial theorem. Feel free to utilize the formula, or if you're more confident with the calculator, as long as there's no variables located in your N or your R, the TI will get you through this just fine. So I will see you in the next example.